Hello and welcome to Mathematics with Simon. I'm Simon. Today we're going to look at quadratic equations as part of the A-level mathematics syllabus. So this is a typical quadratic equation, x squared plus 2x minus 35 equals 0. Now before we try and solve this, we're going to compare it to linear equations. So with a linear equation, or just a normal equation, we've got 4x minus 7 equals 9, that's a typical one. Add 7 to both sides, get the 4x on its own, 4x equals 16. Divide by 4, it's like unpacking a Christmas present. We're peeling off the layers from the x. So divide both sides by 4. X equals 4. Just put it back into check. So 4 times 4 is 16, minus 7 equals 9. It works. It's a bit more complicated with x squared plus 2x minus 35 equals 0 because there's two occurrences of x. But we can notice this trick. X plus 1 squared equals x squared plus 2x plus 1. And then if we take off 36, that's the same as x squared plus 2x minus 35 equals 0. So if we expand out that bracket, the x plus 1 squared bracket, it will be x squared plus 2x plus 1. Then minus 36 becomes minus 35. So this is basically the same equation. Add 36 to both sides. X plus 1 squared equals 36. X plus 1 equals plus or minus 6. And then we take 1 from both sides. We get x equals 5 or x equals minus 7. Because x plus 1 is plus or minus 6. So if x plus 1 equals plus 6, you get x equals 5 by taking 1 off both sides. And if x plus 1 equals minus 6, you get x equals minus 7 by taking 1 off both sides. Okay, x squared plus 2x minus 35 equals 0. So to factorize it, you're basically looking for two numbers that multiply together to make minus 35 and add together to make 2. So those two numbers are minus 5 and 7. So minus 5 times plus 7 gives us minus 35, which is the last number. And then you've got 7 times x is 7x. And then you've got minus 5x. You've got 7x minus 5x, so you've got plus 2x. X squared plus 2x minus 35 is 0. So two numbers multiplied together are 0. That means one of them must be 0. So either x minus 5 is 0 or x plus 7 is 0, which means that either x is 5 or x equals minus 7, which is the same result as before. Now we're going to look at the quadratic formula, which is another way of doing this. So it basically says if ax squared plus bx plus c equals 0, then x equals minus b plus or minus the square root of b squared minus 4ac all over 2a. So we can apply this. So in our case, we've got x squared plus 2x minus 35 equals 0. So a is 1, b is 2, c is minus 35. So x equals minus 2 plus or minus square root of 2 squared minus 4 times 1 times minus 35. So that's 4 times 35 is 140. So it's minus 2 plus or minus the square root of 144 over 2. So the square root of 144 is 12, so it's either minus 2 plus 12 over 2, which is 10 over 2, which is 5, or it's minus 2 minus 12 over 2, which is minus 14 over 2, which is minus 7. Those are the two possible solutions. Same as before. So just to show the proof of this, of the quadratic formula, ax squared plus bx plus c equals 0, then basically we're just going to look at this formula and we're going to use the completion of the square, which is what we did last time, but we're going to do it with a, b and c as coefficients rather than numbers. So firstly we divide by a, x squared plus bx over a plus c over a equals 0. Next, it's going to look slightly odd, but we're going to add b squared over 4a squared in the middle and then take it off again. And the reason for that is these three terms on the left, I've just recopied those back to the top of the page. Those three terms group into x plus b over 2a squared. And then in the end, you've got b squared over 4a squared. You've got minus b squared over 4a squared plus c over a. And then we're just going to add b squared over 4a squared to both sides. And we're going to take c over a from both sides. Then basically we're going to put the right hand side over a common denominator of 4a squared. So we're going to multiply c over a, the top and bottom, by 4a. So you get b squared over 4a squared minus 4ac over 4a squared. Then we're going to take square roots, so x plus b over 2a equals square root b squared over 4a squared minus 4ac over 4a squared. Copy that back up. And then basically, the right-hand side is b squared minus 4ac over 4a squared. Take the square root of the bottom, gives you 2a, because the square root of x over y equals the square root of x over the square root of y. So you've got 2a as a denominator on the right. And then we're going to subtract b over 2a from both sides. X equals minus b over 2a plus or minus square root of b squared minus 4ac over 2a, which you can basically write as x equals minus b plus or minus square root of b squared minus 4ac all over 2a. That's how you derive it. So we've got three methods. The first method was completion of the square. The second method was factorization. The third method is the quadratic formula. And then the final method is we're just going to guess. So basically, you draw the graph of y equals x squared plus 2x minus 35. So we draw that picture. For instance, we notice that when x equals 0, y is minus 35. That gives us 1 point, but we can basically just plot the graph. And then we sort of just do some experimentation. When x equals 0, y equals minus 35. When x equals 1, y equals minus 32, because it's 1 plus 2 minus 35. When x equals 3, you've got 9 plus 6 minus 35 is minus 20. When x equals 5, you've got 25 plus 10 minus 35 equals 0. So x equals 5 is one of the solutions. And then the other one you can do by polynomial division, or the other option is you can just guess but go the other way. So start from put in x equals minus 1. If you put in x equals minus 1, you get 1 minus 2 minus 35, which is minus 37, so it's going down. But then if you put in minus 5, you're going to have like 25 minus 10 minus 35. So 25 minus 10 minus 35 is minus 20. So all of a sudden you're getting closer to 0. And finally, if you put in minus 7, you'll get 49 minus 14 minus 35, which is 0. I hope you like this. If you do, please hit the like button. You're very welcome to subscribe and hit the notification bell. Love to hear your ideas, and most of all, I hope you enjoy your mathematics.